Hey man, it's Freak Bob. Thanks for answering. People usually don't answer. Just having a toll on me. That's why I've been told a couple times. They always say, where's Freaky Bob? But they never ask, how's Freaky Bob?
Damn, bro, Freak Bob just wanted to chat, bro. Freak Bob just wanted to chat. That's all you got. Hold on. So, I actually built this. So, hold on. Let's see. There's a stats one. Oh, that kind of stats. Twitch stats. That's cool. Okay, but what I'm looking for is the freaking this. This is gonna be gears. Okay, so one more time. This is so good.
Hey man, it's Freak Bob. Thanks for answering. People
This video is too good, dude. Alright, so I actually 3D printed the whole thing, but let's just keep working on this. So I had I also built this, which is nothing, but someone handed me the actual part of this, and I took some calipers and I made it. This was pretty fun. Okay, I also did it with this. Okay, this we don't need. Okay, so okay, so the thing that we wait, hold on. Let me do this actually. Oh, I might have to restart. Okay, yeah, that's looking pretty good. So okay, so what are we doing? We are building the actual gear array. So we're gonna have a gear that goes onto here, and then a gear that goes onto here. And so I was watching this video about how you actually do this, but I'm gonna have to rewatch this video. And I'm gonna get my notebook in the truss. Okay, so here is the truss. Uh, okay. The module is the ratio of the pitch diameter to the number of teeth. So wait, hold on. Let's just go to the module is the ratio of the pitch diameter to the number of teeth. Okay. Effectively an angle. Okay. The pitch diameter, the effective diameter of the gear that corresponds to the distance between the effective diameter. It corresponds to the distance between the centers of two gears in mesh. And then Z is the number of teeth. The module can be calculated by dividing the pitch diameter by the number of teeth. Determine the number of teeth. Since you want a 2-to-1 gear ratio, one gear will have twice the number of teeth as the other. Okay. You want the sum of the pitch diameters to equal 15, 30, 45, etc. Why does the... Can we just try that? So we'll set the module to 1, and then this to 5. Um, Oh yeah, center hole diameter. All right. Yeah, I mean that's obviously too small of a gear, but it really doesn't matter. There's got to be a faster way than opening up this stupid dialog box every time. The module is 5, and then this is going to be 10. So then the pitch diameter is 10. So since the module is the same... Hey man, it's Freak Bob. Thanks for picking up. Oh, shit. Components. So then how do you know... Well, do we have the center point, though? We do. This should be... Shouldn't that be 15, though? Wait, no, but that's diameter. That's diameter. So we need to undo this. We need to change... Wait, can we redo? So do you just put 10 and 20? Is that what it is? Yeah. I'll do it again. I'll do it again. Touch me the right way, baby. I'll do it again. What the hell? Oh, Shift S. Maybe I should just do that. Okay, 20. Okay. And now we need to rotate it by the module, which is, it's going to be 20 divided by, it's going to be 360 divided by the number of teeth, which is 20, but over 2. Okay. Yeah, I hate that. There's got to be a better way to do that. Okay, so this is the right thing. So these gears mesh. So these are the gears that I guess I want to use. Because they're 15 apart. Is that what I want? So if we look at this, let's okay, so I'm just going to create it in here, I guess. So this is going to be 1. This is going to be 10. It's going to be 0.5. This could probably be 12 is way too much. We can probably make this 4, and then this is 0. Okay, and then where is the gear? Okay, so we're gonna move this up really quick, and then I'm gonna draw a sketch on here after the position. I'm gonna draw a rectangle, center rectangle. That's gonna be 5 and 5. Oh, is that right? In that case, this is gonna be too weak. And we're gonna need to do, so what if we double it? So let's do that again. And this time, if we do 20 and 40, let's make 40. Then it's gonna be, no, I don't think that's right, because then 20 plus 10 is, oh, that's right. Okay. When you move this, 15 plus, oh wait, minus 15. And then minus 30. Oh yeah. Okay, and so now if we inspect here, the distance between here is 30. And so then if we were to draw a rectangle on here, that's much more reasonable. Wait, what the hell is going on here? Oh, did I do revert position? I must have. Okay, yeah, that's stupid as hell. Okay, so then it's just gonna go in there like, oh, but we need to make it like 5.1 by 5.1. Or maybe 5.15 or something for some clearance. Okay, so that's what we'll do. So we're gonna undo this. Okay. Module is 1. Number of teeth is going to be 20. Because I don't really want to do a set screw. I'm hoping that this is gonna work just as is. Okay, so the first thing is and it is gonna be in there. It's gonna be like, but do we need a spacer? I don't remember in the video if he has a spacer.
Compound gears use multiple gears on the same axle to take a rotary motion input and create a rotary motion output. The direction of travel for the input will be opposite for the gear on the next axle over, but every other axle has the same direction of rotation. To increase torque, a smaller gear.
Okay, it does have a spacer there. Okay. So I actually want to go back. Yeah, this playlist is sick. This is the first one? Okay.
Of 50 millimeters. This number and this name will become important in the next video, so keep that in mind. With all this entered, you can press OK. And then we get a new component, and this component is now our spur gear. What I'd like to do now is design the mounting hub for this gear. And to do that, I will first activate the new component that we just got, and then I will go to Solid, Create Sketch, and then click on the top surface from the edge, or this downwards to the exact length that you need for
Okay,
the shaft
so he extrudes and he
of your motor.
takes a cylinder out of
A
it.
little bit of play, and 10 millimeters plus a little bit of play. And these are the height and the distance between flats of an M6 nut. Next, I hit X for construction geometry and L for line. And from the origin, I will drag out a horizontal line with a distance of 5 millimeters. And finally, what I'll do is I will select this line of this rectangle, and I will select this point, holding down Control. And then to those two objects, I apply the midpoint constraint. And then I can finish the sketch. I now hit E for extrude, and I drag down this profile by 10 millimeters. If you want to make it a little bit more parametric, what you could also do is construct a midplane between the top of the mounting hub and the start of the gear teeth, and then extrude up to that midplane. I'll leave that up to you. The next thing I want to do is create a hole for the set screw to go into. So I will now select this surface right here, create a new sketch. I hit C for circle.
I mean, this doesn't actually avoid the need of a spacer to prevent friction with the... Well, I guess the thing about this is that you can make it so this won't have friction with the... Because you just place it away from the beam. Is that extruded a little bit? I can't tell.
And then I will drag my cursor along this line until we see this little equilateral triangle appear. This is an automatic midpoint constraint, which I do want here. So I click and I drag that out and I type in 6.2 millimeters. That is more than enough to fit an M6 set screw. Finish the sketch, hit E for extrude, and click both of these profiles. And I want to extrude this in two directions. So under direction, I go for two sides. And then on the one side, I simply want to extrude it all the way. And on the other side, I want to extrude it 5 millimeters, which is exactly the same as the 5 millimeters that we had on the length of the construction line before. This extrudes it to exactly the center of the shaft hole. What you can also do, again, if you want to be a little bit more parametric, is instead of a fixed distance, you extrude to an object, and then you extrude to this plane here. And then click OK. And then we have a hole for our set screw to go into. The final thing that we will need is a little bit of a pocket for the nut to go into. And for that, I again click this surface over here, create a new sketch. And what I will do now is under Create, Polygon, take a circumscribed polygon, and then you want to look around here until you get this concentric constraint.
Well, I was kind of hoping to 3D print the set screw, which is why I kind of wanted to... Maybe I should print one of these collars. I wish there was a solo button where you could just solo it. Yeah, I don't know how the hell I'm going to be able to offset this. Maybe I will just... Oh, you know what? I could probably just draw the cylinder. Did I build this in here? I feel like I didn't. Let's see if I... And then this presumably is 5.2. That's 3, but I thought... Oh, but I made the holes 5. I made the holes 5, but I didn't... But the beam is 3. Okay, so I want to print out the beam, and I want to print out this. But I think... Let's see. Okay, and we made this 3. So we should just change this to be like 3.2. Then we should have more clearance, right? But I never actually made the M3. What did I select for the pitch parameters too? 0.5. See, that's not going to work. So we need to... Okay, so we need to open up VS Code and go to that freaking file. Okay, here it is. We need to add a designation. So let's look for M3 by 0.5. We're going to copy this designation. I'm just going to paste this one by 2. Change this to 2. Save that. Okay, I wonder if it auto updates. Oh, nice. It does. You don't actually have to restart. That's pretty cool. I'm curious to see if this can print without supports. Okay, but then I also want to... Let's just do our standard thing. So, well, in this case... In this case, they bore an extra little... hole for the nut. And I'd like to know how far this is to this. Hopefully it will tell me. 10. Okay, let's try it. But yeah, we want to put a But for right now, I just want to see if this works. So let's just try this. So this is going to be 3. Extrude this by 11. Then thread. Okay. Then I want to put a notch on here. And I just want to extrude this by -1. So then I could unscrew it if I wanted or something. And then do we want to actually do the thing with the... Well, we do. We want to Q minus 0.1. And then we want to fill it this by 0.15. Okay. Okay. And then I could just design this fast and it'll take me to freaking open this thing up, but whatever. Okay, so let's save this as a mesh. I'm very curious to see if this thing is going to print. Because I'm not going to give it supports. We ball. Okay, and then we need this. Okay. But we should also design the other type of collar. Oh, wait, but before I do this, is this right? Was this just 3? No, yeah, that's... Okay. So that should be good. Alright, so let's print these things. Okay. I love this auto arrange thing. That's sweet. Okay. And then I guess in the meantime, what I could do is I could design a different one. Like he has.
On the circle that we made before. So I click and just drag this out. The dimension that you get here doesn't matter, but you must here have a 6-sided polygon. You must have a hexagon for a nut. So I just enter that. And what I will do now is remove this dimension that I don't want. I will select this point here in the corner, and I will select this edge over here, and I will give that a midpoint constraint. And then I finish the sketch. I hit E for extrude. I select this profile right here. I drag that out in this direction. And then I want to take as an extent to an object, which is going to be this surface over here. And so that makes the bottom of the cavity hexagonal and with the exact same dimensions otherwise as the pocket that we already created. So click OK. And then we have all the features we need. We have a hole for our shaft, we have a hole for our set screw to go into, and we have a cavity for the nut that will accept the set screw. One final thing that I'd like to show you is how you can export this gear as an STL so you can 3D print it. There are 2 ways to do this, but one way is pretty terrible. The terrible way is to first save your gear. So
I already saw this. That wasn't even that interesting. Dude,
Right
this
now,
video
the gear
series
here,
is
and
so
there are two things
freaking
here that I
good.
wish to show you. First, with the orientation of the gear like this, with the mounting hub on top and the teeth at the bottom, I can ensure that this entire gear can be printed well without the requirement for any support. Second, I have chosen to use 4 perimeters here. And what this allows us to do in the case of this gear with these size teeth is that the gear teeth consist nearly entirely of perimeters. And this gives a maximum amount of strength to the gear teeth. If you have larger gear teeth, meaning that the module of your gear is larger, you may need to increase the wall line count, or alternatively you have to print with fatter lines. So the line width has to go up, and possibly your nozzle diameter has to go up as well. I would now like to show you how you can put this gear on a shaft. So we take the gear, and we take care to align the whole of the set screw with the flat part of the D shaft. And with that alignment ensured, we push the gear over the shaft, and then we take an Allen wrench and a set screw, like this, and then we simply drive the set screw into the hole.
See, that's what it is. A set screw does
set
not
screw.
have...
Into the hole.
Did he already put the nut in, though? He
And
didn't
with that,
show
when we
that.
turn the gear, we notice that the motor also spins. So the gear is now rigidly attached to the shaft.
Cool.
I would now like to show you how you can design basically the same gear, but without a mounting hub, which makes it a little bit more compact. So I make a new design.
Without a
and I go back into the gear
mounting
generator,
hub.
and
Oh,
I add the
yeah.
same parameters
That's
that we used
great.
before. So
I'd rather...
half 20 teeth, a half,
Well-
and 0. And there we have the same gear as before.
Yeah,
I
I'd
take a
try
circle,
this.
And I create a sketch on the top surface. And then I create the same circle as I did before of 8.2 millimeters to go over the shaft. Finish the sketch, hit E for extrude, and then extrude this all the way down again. Again, because I'm lazy, I don't want to match it to the shaft length of the motor. And then we get to a little bit of a different part. So again, we create a sketch on the top surface. And what I want to do is create the pocket now for the nut to go into. So I hit X for construction geometry and L for line. And I drag out a horizontal line here. The length doesn't matter. And then I create a second line from the origin. And I want to give that a length of 5 millimeters. And then I want to specify the angle between this horizontal line and this new line that I drew here. So I select them both and press D. And then the angle that I want here is 360 divided by the number of teeth. And that entire thing divided by 2. And the reason I select this particular angle, and the reason I'm doing this in the first place, is because I want the hole for the set screw to end up where the gear teeth are not. So I want it to land right in the middle of this section here, so that it affects minimally the strength of the gear teeth. So now I create a rectangle, but if I create a rectangle the normal way, then I get these automatic horizontal and vertical constraints. So that doesn't work. So Ctrl Z to get rid of it. And what I'll do instead is just draw 4 lines. And what I'll do now is add the perpendicular constraint 3 times to 3 pairs of lines. And then I give it the dimensions as before. So this will be 10.2, and this will be 5.2. And then as before again, this line has to be on the midpoint of this point. So select them both and then midpoint constraint. And then the final thing that we need to do is select this angled line here and the top end of this cavity that we're about to make and make those parallel. Then we can finish the sketch and then the same as before, extrude it downwards by 10 millimeters.
That makes
From
sense.
here, everything is basically the same as before. So we create a new sketch on this inner surface here. I hit C for circle and I look for this midpoint.
Should I
constraint,
just do
and I
this?
hit 6.2 millimeters. Finish the sketch.
I'll just do this.
Again, 2 sides. And on the one side, I will go for all. And on the other
Because
side, I
I've
will
yet
go
to
for 5
print...
millimeters. And now the point of what we've been doing so far, if I just click OK, is that most of the hole that we've made
Well,
for
no,
the set
I've
screw
made a
does not
gear
dig into
before.
the teeth of the gear. And if you did it the other way, then the hole for the set screw would dig right through this tooth over here, and that tooth would then become quite weak compared to the other ones and would be prone to breaking. So the final thing, as before, create a sketch here. We create a polygon, a circumscribed polygon. Again, look for this concentric constraint to make sure it is a 6-sided polygon, and then take this corner point here, this line here, give it a midpoint constraint, E for extrude, and then this profile.
He only extrudes the bottom part. I
face,
guess
cut it out,
that makes sense.
And then we have basically the same idea, but this gear is much more compact than the previous one. One thing that I neglected to show you before is how you can insert the nuts into the pocket.
Oh yeah, there you go.
Loose, as in this case, then it'll simply drop in. But you honestly want the fit to be a little bit tighter than this. If the fit is a little tighter, what you can do is put the nut inside a pair of combination pliers. If you have a pair of parallel pliers, that would be better. And then leave a little bit of the flats sticking out of the jaw. You can then keep the nut upright as you insert it into the hole. Finally, if you need to drive the nut home to the bottom of the pocket, what you can do is grab a screwdriver and just tap it home with a hammer. And in that way, you can ensure that the nut goes all the way to the bottom of the pocket. You will damage your screwdriver a little bit, but this is a 2-euro screwdriver, so see if I care. This method of attaching the gear to the shaft using only a single set screw does suffer from 2 downsides. First is that there's a lot of force on the nut, and that force is transmitted into the plastic. And because the surface area of the nut is rather small, this creates a very large amount of stress in the material, in the plastic.
Oh yeah, he adds a
PLA
washer.
especially is susceptible to a phenomenon called creep, and this will cause the set screw to come undone over time. Another problem is because we have only one set screw and we are only pushing into the gear from one side, we induce a slight asymmetry. I have hooked up the motor now to a power supply, and I will turn on the power supply, and you can notice that the gear will wobble, it will not run true. Let's now modify the design of this gear to address the problems I have.
We're gonna see. I'm sort of suspicious that this actually produces a force, a clamping force, but we'll see. I hope it does. Ugh. Okay, so If that's the case, then let's just assume that it works, and we'll find out in 10 minutes if it doesn't. Because I really do want to just get it done. Okay, so we are looking at shaft cross section. We need to. Wait, how do I activate this? Okay, so maybe I could just do this again because I did this in I did this on the train, not on stream. So let's just okay, so now what we want to do is we want to insert component. We want to insert. Oh wait, I found a new way of doing this. Bro, why can't I click on this? Hello? Okay, yeah, we need. Oh, this is nice. Okay. So we want this. Can we insert multiple things? Oh, hell yeah. I think I saved the hopefully okay, and this thing updates. That's nice. So we want this. We want the handle, we want the beam, and we want the cross beam. Wait, open? Do I want open? No, that fucking sucks. Insert. Okay, so wait, so you can't. Oh, that's so lame, dude. Wait, does double clicking open it? Yeah, of course it does. Okay, so insert. 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 I guess we will need that, but for right now, I'm not going to do it. Then we need the handle. Okay, so this is going to be a doozy. But basically, and we can look at the, okay, so yeah, so this is what we want. We want the L facing out part to have the handle. Oh, but we need this spacer first. Okay, so I would say to make this easiest. Oh wait, you know, we could probably just disable that, whatever. So we're gonna put this, we're gonna join it. See, okay, I could have. How do you get the hole though? I could just do this and offset it. I'm kind of fine with that. No, but that doesn't work. How did I do this before? I think you just draw a sketch, right? Or let's do it on the second one. Oh, wait, actually, I think the better way to do this is you do this. But then you don't get the point there. Okay, if you finish this sketch, now if I type J, I attach it to this. So that is basically right. Oh, but that's at the bottom one. Can we undo that? Okay, so let's undo the sketch. We don't need this sketch. We are going to make a sketch on here. We're going to do... Wait, but I think that this might be faster. Okay, we finish the sketch. Then we type J. We attach onto this thing. Why did it... Can we hide this? This is probably part of the crossbeam. Okay, cool. And then we just want to move it up like 20. Do 15. Okay, now we want to, if we type J here, do we actually get, we do get that point. It's pretty sweet. Then we should be able to get this point. Okay, and then it doesn't really matter which way it goes, but I do want to just rotate it 180. Okay. And then this needs to go down. Do we have a down to object thing? Oh, we do. Nice. That's sick. A radical brother. Okay, now we just need our handle. And then I think what we do is we do the same thing. Okay, wait, but no, we'll just do flip. So you type this, X, L, finish sketch. Then you take this point, J, hello. What? Dude, I swear, I do not have an intuition for why this never, like, sometimes works and sometimes doesn't. Why did it work on that thing and didn't work on this thing? Okay, whatever. We're going to edit this sketch again. We're going to put a point there. Ugh, annoying. Point. Finish sketch, join. Can I please click on this thing, dude? Holy fuck. Why can't I... I literally have no idea why it doesn't let me do it. Okay, what happens if I, in here, I just click on this and type project? Project this whole geometry. I should get this point. So then when I type join, okay, I don't know. Now I guess I got it. And I want to put it on here. Okay, then I want to flip it. Then I want to move it down to this thing. That seems, oh wait, that thing, but probably 7. 6? No, 7. Okay, so that's that. But this is not far enough. We need to move. Can you move multiple things at the same time? Where are the arrows? What the hell? Okay, first off, we can just delete this. Because, let's see. In this one, yeah, what the hell was I thinking? You won't be able to rotate this thing at all. So okay, fine. So we're gonna move this. Oh, because it's rigidly joined, dude. Oh, you can't move it. So, oh wait, but what you can do is you can go back to the joint, and you can change this to be like 30. Okay. The problem is it's not gonna be long enough. Oh, and then that's perfect. That's exactly what we want. I think so. Okay, nice. So now, is this done? Okay, hold on. I'll go get the parts. Okay, so I think I might need to modify the shaft collar to be bigger. You get a nice fitting. Let's see if anyone can see this. On here, seems tight, but not too tight. But it does slide back and forth, right? So that's the whole thing. But yeah, these threads are. Yeah, I don't think this design is very good. I mean, there's just no way I'm going to be able to get this thing in here. Oh, but you know what? I think when you thread this, I think right, but if I pick this, the hole becomes smaller. So even though I made the cylinder in the even though I made it 3.2 with clearance, it basically disrespected that. Okay, so let's try to make one of those gears that I can just set in place. How about that? Okay, so we're just going to make this first gear with set screw gear. Okay, so we're going to make the gear. It's going to be module of 1. The number of teeth is going to be 20. This is going to be 0.5. This is going to be 4. This is going to be 0. Then okay, so now we're going to have to watch this video and actually pay attention. We can probably start from here.
A bit more compact. So I make a new design, and then I go back into the gear generator, and then I add the same parameters that I used before. So a module of 2.5, 20 teeth, 1/2, 20, and 0. And there we have the same gear as before. I activate this component, and I create a sketch on the top surface, and then I create the same circle as I did before of 8.2 millimeters to go over the shaft. Finish the sketch, hit E for extrude.
Okay, so my shaft. Oh, okay, and then I could probably do this, an alternate shaft that's circular. Because presumably I could also in here I could do the same thing. Well, I don't really have the width. That's the thing, is that I want the gear to be thin, but he uses so much depth there. Oh wait, this screw is going through actually. See if we can. I'm gonna need like pliers. Okay. Well, and then the other question is whether or not okay, yeah, so the other design that we could do. Is this empty? Yeah, this is basically empty. Okay, so is we could what is the diameter? The diameter is gonna be fuck, I don't even know. Let's go to, do we have the radius is 6, so we made it 12. I think that was arbitrary. Okay, so yeah, 12. And we can make it bigger. Let's make it 14. Okay, we're gonna draw a rectangle here. That's center rectangle. That's 3.15. Is that right? Or is it 3.3? Was it 3.2 by 3.2? because this one we want to be tight-ish, so that it just has multiple things holding it. Okay, then we take this and we extrude it, but we also want. Okay, yeah, we'll do that, and we'll extrude it by 5. Is that enough? Oh. Okay. Then I guess we'll look at the front face here. We'll draw a sketch on here, but we'll project this whole thing. And actually, can we project? Okay, so we have these points. So now, but we don't have this center point, but that's fine. We can make that. What is it that we were trying to do? Yeah, we're trying to find that center point and draw a circle around it. So let's make it, let's just do this. I don't know if this is the right way to do it, but we do what we want around here. Okay, so this wants to be 5.2. No, it's gonna be 5, but then we have to. Oh, wait, is that the diameter? Okay, so what we want to do is we want to finish this sketch, go back to this extrusion, and make it 8. It's gonna be a chunky boy. Oh, it's gonna be too chunky. Can we do a 4? Can we make it 6? Let's try to make it 6. Actually, that's maybe enough. Okay, so now we go back to this sketch. And we want to make this not construction geometry because we are going to extrude this. Distance all the way. Okay, so then the shaft like goes through there, and then this design doesn't have a washer at all. It just no, or I mean, it doesn't have a nut. But I feel like that's actually so stupid. I feel like you kind of need a nut because what else is gonna prevent creep? Well, we could try this because this is only a demonstration thing, so it's not like the end of the world if it doesn't go that bad. But so we still need to do this though, where we thread, but the problem is threading here sucks. Because you to select all of these is like a total pain in the butt. Oh, and you know what? We have to cancel this because we didn't want to. I think I drew on the wrong thing. So let's undo all of this. Okay. So we want to take this face and we want to draw on it. Can we? How do you do an offset face tangent to this thing? No, see, that's stupid. I want tangent plane. Oh, that's sick. That's exactly what I want. And then if we look at the top, is it actually a right angle to it? Okay, that's perfect. Okay, so I want to draw on here and bore into this wall. So we're going to draw on here, and then we're going to project this, and we're also going to project this. Okay, then we're going to draw 2 lines, both construction. Okay, then we're going to draw C here, and this is going to be 5, right? Oh, wait, what happened? We could do 4. I think this little thing was 3. Well, where's 4? Oh, well, apostrophe? That's a funny parsing thing. Okay, so yes. So let's just do this. Extrude to here. Wait, no, that's stupid. We do need to go to the middle, right? Because for it to collide with it. All right. So let's undo that. Let's extrude, and then let's view the origin plane, which is, let's hide this. We're gonna go to here. We're gonna re-enable it. Okay, so that's fine, I guess. And then we're gonna, so this is the same thing, just done way harder for no reason. Okay, so we're gonna thread this M4 by 2. That's correct, at least. And then I'm fine having the head sticking out. Okay, but we do need to do this at the very least. Minus 0.1. And then fill it. Okay. So we're going to see if we can get that. And then we can just print out a normal... Okay, so let's do this. Set screw collar. No nut. Whatever. No nut. Okay. Hopefully that can be printed. All right, so let's save this as a thing to print, and then we'll print also an M4. Okay. And then in my lib, oh, I don't have an M4 yet. Okay, fine. At some point, I really have to automate this because I've done this so many times. Okay, so so this needs to be 6. No, that's too big. This needs to be 3. And then we need to draw 4. Oh, wait. And then this should be like 3. Wait, 2. 3. 2.5. That sounds good. I mean, yeah, there's no standardization. We just get shit done here. And it's gonna come back to bite me. Okay, now we're gonna extrude this by I think 8, right? Then we're gonna thread this. Okay, that's good. Then we just want to select this face Q minus 0.1. Then we want to select this face 0.15. Okay, now we have the bolt. Now we need to create a new sketch. Oh wait, I always forget this thing. New component from body. Where's the from body? body. M4 by 2 bolt. Okay. New component. M4 by 2 nut. Okay, here. Then we want to create a sketch. Hide this. Yeah, we're gonna sketch on here. And then we just want, and we'll just move it. This is also going to be not a circle, but a polygon. Oop. Fuck. Polygon. The arrow keys, but the tab doesn't work, which is fantastic. Okay. Here, this is going to be 3, right? Then we want to do this, this. Okay, then we want to extrude this by, how much did we say? 2.5? That's probably not enough. The nut probably has to be 3. So there we go. Another weird inconsistency, but oh, and you know what I could have done actually to save a sketch? I probably could draw the circle here, and this is going to be 4, right? And then I could just extrude this by 3. And then I can do this and thread that. And this can be 4 by 2 modeled. Okay. See, but you only get like 2 threads worth. So I've heard somewhere where you need like, oh wait, that's not the right. You need like 3 threads for it to be worth anything. But who cares? Okay, so now we can re-enable this. We can select this, move this, and just shift it over. Okay, cool. That's not bad. So this is going to be M4 by 2. Save this. And then we want to also, how did I do this? In my files, I have, is it pictures? My lib. Did I just save? Oh, I just export. Okay, that's fine. So let's just do that. Save mesh as. And then we want to change this to my lib. Save that. Okay, then we want to save this one. Save mesh as. Okay. Okay, perfect. Nice. So that wasn't too bad. So then what we're going to do is we're going to add set screw collar. Oh, wait, did we already do that? Whatever. Okay, then we want to add, and then just for funsies, I'm going to do these both, even though we don't really need the nut. Okay, so then what you want is auto orient and then auto arrange. Okay, and then we're going to see how that is. Slice, print. Yeah, Glow. Curbing, uncurbing, your shit is stale, ho. Yeah, Glow. Okay, Fwick. what's next? We're gonna test that out, but then I guess we should just keep working on this thing. I don't know if there's like a find and replace ability though, but we could just keep using copy, paste, and we do want to keep them the same, so we're gonna paste it, and we're just gonna shift it, and if I select this face, hold on. It's moving with respect to the center, but I want to offset it by there. That seems right because you can select that edge. Okay. So then, did I have a gear 1 file, I thought? We can close this now because we already did that. We don't need the handle, really. Set screw gear. Oh, yeah. Was I going to do this? Well, we don't really need to do this until we know that that the set screw without a nut works. But it would be nice to have like a real part. So maybe we could try that. Maybe we'll do, just for practice, we'll do both of these with the hub extension or whatever and without. Dude, planetary gears. Ooh, bevel gear. I kind of want to see that. That looks cool. Ooh, worm gear. Oh, bro, this guy is goated. Yo, shit is stale. Oh, yeah, glow. Curbing on curbing. Yo, shit is stale. Yeah, Glow is such a good song. Okay, let's fucking lock in. Let's do this then. We're just gonna commit to
Tools,
doing
and under
this.
add-ins here, you go to scripts and add-ins, and then this dialog pops up with a bunch of scripts that are already installed. And if you scroll all the way down, you will find 2 instances of the Spur Gear script. As far as I know, it does not matter which one you pick, so you can just click run. And then this dialog comes up, which asks for a bunch of parameters for your gear. I will explain what all these parameters mean in a later video. For now, I will just pick a few parameters that will make sense later. For the module, I will go for 2.5, and I will design a metric gear with a pressure angle of 20 degrees. Number of teeth, 20. Backlash, I will leave at 0 for now. A root fillet radius of 0.5 millimeter. I want my gear to be 20 millimeters thick. And I prefer to make the hole myself later on. You will see why that is at that time. So I will put the hole diameter to 0 so that no hole is generated. And at the bottom now you can see that it gives a pitch diameter of 50 millimeters. This number and this name will become important in the next video, so keep that in mind. With all this entered, you can press OK. And then we get a new component, and this component is now our Spur gear. What I'd like to do now is design the mounting hub for this gear. And to do that, I will first activate the new component that we just got, and then I will go to Solid, Create Sketch, and then click on the top surface of this gear. I then hit C on the keyboard for circle, and then from the origin I drag out a circle, and let's say we make it 30 millimeters. But I'm going to 3D print this gear, and I want this mounting hub to be as strong as it can be. So instead of giving it a fixed dimension, I will just delete this. What I will do instead is select this inner little edge right here on the inside of the gear teeth, and hitting Control, I also select the circle that we just made. And to those 2 edges, I apply the equals constraint. And this now makes the mounting hub as large as it can be without interfering with the gear teeth. So I finish sketch, I hit E for extrude, and then I will extrude this 20 millimeters upward. Next, I would like to
Wait, what does he call it?
as it can be without interfering. And this now makes the mounting hub as large as it
Mounting
can be without interfering
hub.
with the gear teeth.
Yeah.
So I finish sketch, I hit E for extrude, and then I will extrude this 20 millimeters upward. Next, I would like to make the hole for the shaft to go into. For that, I will create a sketch on the top surface of the mounting hub. Hit
Okay,
C for
so
shaft.
let's do that. Oh wait, what am I doing? I'm so built into just starting everything with that. Okay, so what did he do? He did 20, 2.5, 20, 0.5. Did he do 20 here and 0? That sounds right. Okay, then he activated this component, drew a sketch on here, and he drew a circle, but then he selected this and made them equal. Okay, then he took this, and extruded it by 20 more, right? Okay, so there we go. That's the start.
And then from the origin, I draw a circle of 8.2 millimeters. In my case, I want to mount this gear on a motor, and that motor has a shaft diameter of 8 millimeters. I also know that my printer tends to print holes that are slightly smaller than they need to be, and so to compensate for this, I make the holes just a little bit larger in Fusion 360. Hit enter on this, finish the sketch.
I would like
Then
to try to mount this to the shaft of the... I mean, because what you would want is you would want to drill through the whole shaft and go from one side of the gear to the, or one side of the mounting hub to the entire other part of the mounting hub. Oh, this is almost done. Okay, so we'll find out in a second. All right, let's keep watching.
You could extrude this downwards to the exact length that you need
Wait,
for
but
the shaft.
Is it this? I'm pretty sure it's this actually. Curbing on curbing, your shit is still how. I thought I was trying to do this split bodies thing. Yeah, it's so lame because I really want to make that thing rotate. Regardless, the outer diameter of the shaft is 5. So we should make ours 5.
Length of your motor, but you can also go the lazy way and just extend it all the way. And then press OK, and now we have a hole for our gear. The next thing I would like to do is make a cavity for a nut.
All right, so let me just do that. I'll just follow it step by step. See. Wait, did he add clearance though?
To go into. But you can also go the you need, and then this, finish the sketch.
Yeah, he did.
Fusion 360.
Wait, if I do this. Oh. Hey, what the flick?
Hit enter on this, finish the sketch, then hit E for extrude, and then you could extrude this downwards to the exact length that you need for the shaft length of your motor, but you can also go the lazy way and just extend it all the way. And then press OK, and now we have a hole for our gear. The next thing I would like to do is make a cavity for a nut to go into. So I create another sketch on the top surface of the mounting hub, and then I hit R for rectangle. I drag that out, and then I hit D for dimension, and I will give this a dimension of 5 millimeters plus a little bit of play, and 10 millimeters plus a little bit of play. And these are the height and the distance between flats of an M6 nut. Next, I hit X for construction geometry and L for line, and from the origin, I will drag out a horizontal line with a distance of 5 millimeters. And finally, what I'll do is I will select this line of this rectangle, and I will select this point, holding down Control, and then to those two objects, I...
M6. I need to check if I even have that. Okay. Let's go get our stuff, though. Okay. It's kind of crazy how small 4 millimeters is. Okay. Gosh, I should have got the pliers. That's pretty strong, actually. I mean, yeah. If you tighten it, once it comes loose, though, it's loose. That's the problem. But I think that might be good. So maybe we'll just use this design. Okay, I kind of need to take a shit. I will be back. Okay, so. Alright, I'll be back in a minute. Okay. So I have metal M5 nuts, but the pitch on those is definitely not 2 millimeters, probably a half or something. So that means that when I thread the... Does he even do that, or does he just have a cylinder?
Apply the midpoint constraint. And then I can
But anyways, I won't make it an M6. However, what I realized is if I want to put it in the shaft, if I want to put the actual stepper motor shaft in this thing, and I use all 3D printed components, it doesn't matter how hard I tighten it, because there's just no way that plastic is harder than steel, so I'm not going to mar the surface of the flat. So it really doesn't matter. But that being said, getting the size of this nut right is... I could do an M6. Why not? Let's just do that. Okay, let's just do that. So we're going to draw surface here. We're going to do LX here, 5. Okay, then we're going to draw a rectangle like this, and it's going to be 5.2, and what did he say? 10.2? And then... okay, then here... That's it, right?
And finally, what I'll do is I will select this line of this rectangle, and I will select this point, holding down Control, and then to those two objects I apply the midpoint constraint. And then I can finish the sketch. I now hit E for extrude, and I drag down this profile by 10 millimeters. If you want to make it a little bit more parametric, what you could also do is construct a midplane between the top of the mounting hub and the start of the gear teeth, and then extrude up to that midplane. I'll leave that up to you. The next thing I want to do is create a hole for the set screw to go into. So I will now select this surface right here, create a new sketch. I hit C for circle.
Whoa. I'm also going to need to design the M6 nut, but that's just more of the same.
Gear teeth, and then extrude up to that midplane. I'll leave that up to you. The next thing I want to do is create a hole for the set screw to go into. So I will now select this surface right here, create a new sketch. I hit C for circle.
Bro, I am out of it. What the fuck?
And then I will drag the sketch. I hit C for circle, and then I will drag my cursor along this line until we, and then I create a new sketch. I hit C for circle,
Oh,
and then I will...
okay. Okay.
drag my cursor along this line until we see this little equilateral triangle appear. This is an automatic midpoint constraint, which I do want here. So I click and I drag that out and I type in 6.2 millimeters. That is more than enough to fit an M6 set screw.
Right.
Finish the sketch, hit E for extrude, and click both of these profiles. And I want to extrude this in two directions. So under direction, I go for two sides. And then on the one side, I simply want to extrude it all the way. And on the other side, I want to extrude it 5 millimeters, which is exactly the same as the...
Okay. No. Two sides. This one. All. This one. 5. Cool. Wait.
5 millimeters that we had on the length of the construction line before. This extrudes it to exactly the center of the shaft hole. What you can also do, again, if you want to be a little bit more parametric, is instead of a fixed distance, you extrude to an object, and then you extrude to this plane here, and then click OK, and then we have a hole for our set screw to go into. The final thing that we will need is a little bit of a pocket for the nut to go into.
There we go.
And for that, I again click this surface over here, create a new sketch, and what I will do now is under Create, Polygon, take a circumscribed polygon, and then you want to look around here until you get this concentric constraint on the circle that we made before.
Okay, let me just watch 2 minutes of this and try to
What you can also do,
it.
again, if you want to be a little bit more parametric, is instead of a fixed distance, you extrude to an object, and then you extrude to this plane here, and then click OK, And then we have a hole for our set screw to go into. The final thing that we will need is a little bit of a pocket for the nut to go into. And for that, I again click this surface over here, create a new sketch. And what I will do now is under Create, Polygon, take a circumscribed polygon, and then you want to look around here until you get this concentric constraint on the circle that we made before. So I click and just drag this out. The dimension that you get here doesn't matter, but you must here have a 6-sided polygon. You must have a hexagon for a nut. So I just enter that. And what I will do now is remove this dimension that I do not want. I will select this point here in the corner, and I will select this edge over here, and I will give that a midpoint constraint. And then I finish the sketch. I hit E for extrude. I select this profile right here. I drag that out in this direction. And then I want to take as an extent to an object, which is going to be this surface over here. And so that makes the bottom of the cavity hexagonal and with the exact same dimensions otherwise as the pocket that we already created. So click OK. And then we have all the features we need. We have a whole
Cool. Let me try that. You first have to do sketch. Then you have to do polygon. You gotta find that thing. Okay. Okay, that's it. That's sick.
shaft, we have a hole for our set screw to go into, and we have a cavity for the nut that will accept the set screw. One final thing that I'd like to show you is how you can export this gear as an STL so you can 3D print it. There are two ways to do this, but one way is pretty terrible. The terrible way is to first save your gear, so let's call it video gear, and then...
So that's it, right? So should I just make an M6x2 set screw? Do I have M6? I don't think I do. M4, M16, M8. Yeah. Okay, here we go. Oh, wait. Let's save this one as gear with mounting hub set screw. Okay. We can close this, I think. We can close this. Okay. So, so what's going on? We need to, okay, yeah, what the hell am I talking about? Am I an idiot? So this one needs to be 5, right? Then we extrude this by 5, right? Then we draw on here, make a circle of, this is for an M6, right? So 6. Then we need to extrude this by however long we want. I'm curious how long it is from here to here. 34? Okay, so we'll make 2 designs then. This is going to be the normal one, so we're going to just make this like 10. 12. Damn it. Every time. Okay. Two. 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 Save that. Nice. M6 by 2 bolt L10. Let's just do this. Nope. Oh, oh wait. This is a Oh, I hate that it's blue. It's impossible to tell. I think that's right. Okay. M6. Okay. New component. We'll do M6 by 2 by 15 set. Screw. Oh, wait. Okay. So now here, oh, it's hollow in the middle? Mmm. So the outer diameter, within the inner diameter will be 4. Okay. I'm trying to think about what the easiest way for me to do, because okay, well, let's just do this. Okay, well, then we're gonna draw on here. And this is gonna be 2. And we're just going to hollow out maybe. I mean, that is really weak. But that's fine. Okay. That's not so bad. Okay. Should I make it hex? I don't even know if I have a... Should I give it a little bit of clearance? I mean, I really don't have that much room. Maybe it'll be fine. So now I just need to move it. I think I do have metric Allen wrenches. Okay, so let's print this damn thing. And then let's also print a let's just do this. Okay. Did I say 60? What did I say? Doesn't need to be 60. Well, it actually does kind of need to be 60 because this thing is so freaking big. Chonky boy. Okay. Okay. Now we just gotta... We literally don't even need to save this because it's such little... Okay, but this I do want to save. Okay, cool. So, oh, we didn't export this yet, too. Oh, wait, let's, this is more of a... God, keeping this organized is terrible. Okay, so we need this, need this, and we need this. Then we need... Oh, and we forgot the, this and this. Okay. That it? Okay. I trust it. Let's do this thing. Okay. I'd like to try the other one too. The other one though, yeah, it's...
If you wanted to save, you can go to File, Export, and then if you scroll down a little bit on the file type, you can export it as an STL. And then you get this cloud translation, which may take a few minutes and all that good stuff. So we export it, and then we have to wait for this to finish. This is the terrible way. The better way to do it is to simply go under Tools, under Make, and then 3D Print. And then in this dialog, I prefer not to send it through to a 3D print utility. The reason for that is every time you do that, a new instance of Cura is opened, and that leads to a lot of instances of Cura at some point. And then I select the component I wish to 3D print. You can also select bodies if you prefer. And then I hit OK. And then I can just save this. The file name is already set to the name of the component. I can save it, and then it's immediately done. And if we go to our job status, we see that this exporting via cloud translation is still going. I've now opened the gear in Cura, and there are two things here that I wish to show you. First, with the orientation of the gear like this, with the mounting hub on top and the teeth at the bottom.
Oh, I didn't check the I'm sure it'll be fine. All right.
I would now like to show you how you can design basically the same gear, but without a mounting hub, which makes it a little bit more compact. So I make a new design, and then I go back into the gear generator, and then I add the same parameters that I used before. So a module of 2.5, 20 teeth, a half, 20, and 0.
Damn, he was fast with that.
I activate this component, and I create a sketch on the top surface, and then I create the same circle as I did before of 8.2 millimeters to go over the shaft. Finish the sketch, hit E for extrude, and then extrude this all the way down again because I'm lazy, I don't want to match it to the shaft length of the motor.
Okay, so let's okay, so let's do this. Okay. 2.5, 20, 0.5, 0. Oh wait. 20, 0. Okay, then
and then we get to a little bit of a different part. So again, we create a sketch on the top surface. And what I want to do is create the pocket now for the nut to go into. So I hit X for construction geometry and L for line. And I drag out a horizontal line here. The length doesn't matter. Then I create a second line from the origin. And I want to give that a length of 5 millimeters. And then I want to specify the angle between this horizontal line and this new line that I drew here. So I select them both and press D. And then the angle that I want...
okay. Oh yeah. Right, I get it. L. I hate that you can't press X while you're drawing the line. I feel like you should be able to do that. Give me 360 divided by 20 divided by 2. You can't do minus? Okay.
One here is 360 divided by the number of teeth, and that entire thing divided by 2. And the reason I select this particular angle and the reason I'm doing this in the first place is because I want the hole for the set screw to end up where the gear teeth are not. So I want it to land right in the middle of this section here so that it affects minimally the strength of the gear teeth. So now I create a rectangle, but if I create a rectangle the normal way, then I get these automatic horizontal and vertical constraints. So that doesn't work. So Ctrl Z to get rid of it. And what I'll do instead is just draw 4 lines. And what I'll do now is add the perpendicular constraint 3 times to 3 pairs of lines. And then I give it the dimensions as before. So this will be 10.2, and this will be 5.2. And then as before again, this line has to be on the midpoint of this point. So select them both and then midpoint constraint. And then the final thing that we need to do is select this angled line here and the top end of this cavity that we're about to make and make those parallel. Then we can finish the sketch and then the same as before, extrude it downwards by 10 millimeters. From here, everything is basically the same as before. So create a new sketch on this inner surface here. I hit C for circle and I look for this midpoint constraint. I make it 6.2 millimeters. Finish the sketch, E for extrude. Again, 2 sides. And on the one side, I will go for all.
Okay, I'm pretty sure that's it, right? Then he extrudes it. Then he makes the circle. Okay. Yeah, you have to do... Whoa. Cancel, cancel, cancel. Wait, did I do that right? No, I didn't do that right. He extrudes at minus 10, right?
Or extrude it downwards by 10 millimeters. From here, everything is basically the same as before. So
Then
I
he
create a new
draws
sketch on
a
this inner surface
circle.
here. I hit C for circle, and I look for this midpoint constraint. I make it 6.2 millimeters. Finish the sketch, E for extrude. Again, 2 sides. And on the one side, I will go for all. And on the other side, I will go for 5 millimeters. And now the point of what we've been doing so far, if I just click OK, is that most of the hole that we've made for the set screw does not dig into the teeth of the gear. And if you did it the other way, then the hole for the set screw would dig right through this tooth over here, and that tooth would then become quite weak compared to the other ones and would be prone to breaking. So the final thing, as before, create a sketch here. We create a polygon, a circumscribed polygon. Again, look for this concentric constraint to make sure it is a 6-sided polygon, and then take this corner point here, this line here, give it a midpoint constraint, E for extrude, and then this profile, you go up to this face, cut it out, and then we have basically the same idea, but this gear is much more compact than the previous one. One thing that I neglected to show you before.
Oh, nice. You can sketch. Oh, that's really useful, actually. I like that a lot. Why is it 5.265? So that's the whole thing. That's pretty nice. And nothing gets threaded because that's pretty nice. So this is gear, no mounting hub set screw. Okay, cool. Ooh, this is probably a good one. Let's just work through this whole thing.
How you can insert the nut into the pocket. Now, if the fit is quite loose, as in this case, then it'll simply drop in. But you honestly want the fit to be a little bit tighter than this. If the fit is a little tighter, what you can do is put the nut inside a pair of combination pliers. If you have a pair of parallel pliers, that would be better. And then leave a little bit of the flats sticking out of the jaw. You can then keep the nut upright as you insert it into the hole. Finally, if you need to drive the nut home to the bottom of the pocket, what you can do is grab a screwdriver and just tap it home with a hammer. And in that way, you can ensure that the nut goes all the way to the bottom of the pocket. You will damage your screwdriver a little bit, but this is a 2-euro screwdriver, so see if I care. This method of attaching the gear to the shaft using only a single set screw does suffer from 2 downsides. First is that there's a lot of force on the nut, and that force is transmitted into the plastic. And because the surface area of the nut is rather small, this creates a very large amount of stress in the material, in the plastic. And as I've shown in my previous video, PLA especially is susceptible to a phenomenon called creep, and this will cause the set screw to come undone over time. Another problem is because we have only one set screw and we are only pushing into the gear from one side, we induce a slight asymmetry. I have hooked up the motor now to a power supply, and I will turn on the power supply, and you can notice that the gear will wobble, it will not run true. Let's now modify the design of this gear to address the problems I have brought up. First, I will add a cavity for a washer to reduce the stress in the plastic and thereby reduce the creep that the plastic will experience. So I will create a new sketch and then put that on this face over here, hit C for circle, and then look for this concentric constraint, and then I will give that 20.2 millimeters. This is for 20 millimeter washers, and then I give it a little bit of extra space to ensure that I can push it in later. Finish the sketch, hit E for extrude, I will select both of the profiles, and then I will drag that out by 1.5 millimeters. This is a little bit more than the thickness of my washers. The next thing I will do is create a sketch on the top surface of the gear, and then I will hit P for project, and I will project that circular cavity I just made into my sketch. And then on the view cube, I hit top so I can get back into the correct view. I hit L for line, and I connect these 2 lines over here so that I can get a complete profile. I finish the sketch, I hit E for extrude, and I select these 2 profiles over here, and I drag them down. And I will drag them to an object, and that object will be this circle over here. And I click OK, and now I have a nice cavity for the washer to go into. The final thing I wish to do is mirror all of these features to the other side of the hole to balance out the forces and to prevent the concentricity error I talked about before. To do that, I will go to Create, Mirror, and then the pattern type will be Features, and the feature I want to mirror is both the washer features and this pocket feature and the hole, and also this feature over here, and then the mirror plane will be this plane over here. And so now everything is being mirrored to the other side. I click OK, and then I do indeed get everything twice. I have 2 cavities for nuts, I have 2 cavities for the washers, and now if I look at it from this angle, I have 1 hole going straight through the gear. So now I can add 2 set screws to balance out the forces that this gear will experience, and thereby prevent the concentricity error. I've now mounted this new design to the motor. As you can see, if I give this a half turn, you can see the set screw on either side. And I will now turn on the power supply to show you the concentricity error. So to my eye, the concentricity does seem to be improved, but as you can clearly see, it is still not perfect. And I think the reason for this is that the X gantry of my 3D printer, which is a CR20, is sagging slightly because the lead screw to support it is on only one side of the machine. The other side is essentially free floating, and so that side sags down ever so slightly, which causes the axes to no longer be perfectly perpendicular. In particular, this means that the shaft hole that we drill here, or that we print rather, is not completely perpendicular to the faces. I would now like to show you a different way of attaching a gear to a shaft. This gear has a hole all the way through the mounting hub, and on the other side we find a nut, which will accept this screw. And what we'll do now is put the shaft through the gear, and then we have to line up the hole in the shaft with the hole in the gear.
Oh,
This is
yeah.
a little bit tricky to find.
Yeah, this is what I was saying.
You can use the pliers to give yourself a little bit more leverage. And once it's lined up, you can insert the screw and push it to the other side. And then once it engages with the nut on the other side, you can use an Allen wrench to tie the screw into the nut. And then we have our finished result. The benefit of using this technique is that you can transfer an enormous amount of torque through this system. There is no way for this mechanism to come loose due to a simple deformation. For this mechanism to fail, something has to break.
Yeah.
Either the shaft, or the screw, or the gear itself has to break into pieces, or otherwise this mechanism will stay intact. We're now back in Fusion 360, and I've already designed some features of the gear. So the teeth are already there, I've already made the mounting hub, and I've already made the hole for the shaft. In this case, the hole for the shaft is 10.2 millimeters, because I want to mount this gear on a 10 millimeter shaft. What I'll do now is create sketch, and hit one of these vertical planes. I hit P for project.
Dude,
and I
he's
project
so
this
good
part
at
into my
this.
sketch. I hit X for construction geometry and L for line, and I go from this midpoint here upwards to this midpoint over here. I want a line going straight up. I disable construction geometry and hit C for circle, and I look for the midpoint of the line that I just made, and I give that a diameter of 4.2 millimeters because I want to put an M4 screw through it later on. I finish the sketch, I hit E for extrude, I go to 2 sides, and then on both sides I will select the extend all. And then it bugs out, it unselects the profile, so just select it again, and then press OK. So now I have a hole through the mounting hub of my gear. I'd now like to add a small cavity for an M4 nut to seat into. To do that, I will first construct a tangent plane, and the plane will be tangent to the mounting hub. And for the reference
Dude,
plane, I will
tangent
pass
plane
the
is
origin of the
sick.
gear, and then I will select this plane. And this will ensure that the plane I am constructing is perpendicular to the hole. Then I create a sketch on this new plane, and as before, I hit P for project to project the gear into my sketch. And as before, I can't really select an automatic concentric constraint here. So again, I press X for construction geometry and L for line, and I draw a line like this. And now what I want to do is go to create, polygon, circumscribe polygon, and then from the midpoint, I draw out a polygon like this. Again, 6-sided. The distance between flats now is 7
I know
meters.
what
If
he's
you want this to be
doing.
quite tight, you can force the nut in, and then it'll stay there due to friction. And then to constrain it fully, we select one of these edges and give it a vertical constraint. We finish the sketch, we hit E for extrude, and then we extrude this inward by about 5 millimeters. What I'd like to do now is make a pocket for the head of the screw to fit into. To do this, I create another tangent plane, tangent to our mounting hub, and then the reference plane will be this plane that we made before. And for the angle, I will give it 180 degrees, so it ends up exactly at the opposite end of the mounting hub. Now we create the sketch onto this new plane, hit P for project, and now I want to be a little bit more careful with what I select for projecting. So I'll select this line up here, and this little line down here. And the reason for that is that otherwise I get too many profiles that are available for extruding, and then I have to go through the effort of selecting the right ones. So hit OK, and then on the view cube,
Dude, mechanical engineering is so cool. design. So cool.
Just hit left so I can get a better view again. X and L for construction line, and draw that up like this. Then disable construction, C for circle, and I'll make this circle 7.5 millimeters thick because it's better if the screw fits quite loosely in here. This doesn't need to be tight. Then hit E for extrude, and then extrude the entire thing 6 millimeters down because the head of the screw is a little bit thicker than a nut. Hit enter, and there we go.
One of the difficulties in using this technique is that you must drill a hole through the shaft that is central on the shaft. It must not be off-center because then the alignment won't work. And this is more difficult than it seems because as you try to press the drill bit into the steel, if you are off-center ever so slightly, the drill bit will tend to wander off that way or the other way. And so getting this hole nice and centered is quite tricky indeed. For this, I have designed a special jig. And this jig consists of a lower and an upper part. And then on the bottom end here we have some nuts which we will use later for clamping. And then we just have the steel shaft in this little channel. And then we put the top half on top. And then we can simply use some bolts to close up the jig. I've now closed up the jig, so we have the bolt heads on top, with the nuts here on the bottom, and in the center now we have the shaft. And on the top end here we have a small little hole which will guide the drill into the shaft. So we can now put this on the vise, and close it up. And now we can start drilling. So I now try to locate the hole with the drill bit, and then push it down, and now the jig will guide the drill bit centered on the shaft. So we now have a completed hole, but there is now a little downside to the jig. And that is that the chips that have been evacuated by the drill bit upwards into the jig have now enlarged this hole substantially. And so now the top half of this jig is not really usable anymore. So here's a previous one that I used before, and you can see this one is also not usable anymore. But now let's open up the jig, and I'll show you the result. So I've removed the bolts, and here we have our result. You can see that the hole is nice and centered on the shaft, though you should note that because I was slightly careless, the two holes now that are in the shaft are not exactly parallel. Nevertheless, both of these holes should work for mounting this gear, so let's give this a try. And I will grab my wrench, my pliers rather, put this in the right position, and now I should be able to ram the screw in there. Grab the Allen wrench, and you can tighten this down. You may have noticed over the past few shots that the screw of this gear is a little bit too long. But I would like to point out that the reason for this is because this screw has a piece of smooth shank, and it is this smooth shank that is in contact with the shaft, and this ensures a higher amount of strength and also provides a little bit less backlash. But what I want to do now is cut this screw off to the correct length, and for that there is another special trick. So I will make a mark where I want to cut the screw off, and then I'll go cut it.
Dude, I just use a freaking
So I put the screw
Dremel
in the vise
tool.
now, and you can see the cut mark right here that I want to make. And on the other end of the cut mark, I've inserted 3 nuts, and the reason for that will become apparent in just a second.
I forgot why he did this.
So now I've cut off the last bit of the screw that I do not want, and if I open up the vise and you look closely at the thread, you can see that it is slightly damaged. And the nuts now will act as a sort of die to reform the thread into what it needs to be. So this basically undamages the thread by unscrewing these nuts. And it gets easier for the third nut than it was for the first. I'm not completely happy yet with this screw because there's a slight sharp burr here that I want to remove. So I've put 2 nuts again on the threaded section, and I can just take a file and get rid of that little nubble that I do not want. So that's smooth now. And then I can take the screw out of the vise again, and again threading the nuts back over the piece of thread that I just damaged. This doesn't work. So I will need to use my pliers instead. I misspoke, of course I'm not going to use my pliers, I'm going to use my vise. Now this should fit nicely into our gear. So here we have our gear, put the screw in like this, take a wrench, and we can thread it in. And now we have everything we want. The screw is
This video is sick.
The head of the screw is also nicely inside the mounting hub. And here we see again that the smooth shank is in contact with the shaft. And this again ensures the maximum amount of allowable torque and also reduces the amount of backlash. I hope you found that interesting and informative. In the next video, we'll be taking a look at what parameters you need to select for your gears. And one example we'll cover is this Archimedes screw pump. Now, in today's video, we've designed this gear over here, but the action of the pump is done with this shaft down here. And what we want to do now is connect this shaft to this motor via 2 gears over here, so we need to design the matching gear for this gear that we already have. I'd like to thank you very much for watching. Don't forget to hit one of those buttons on your way out, and have a great night.
Hi. In today's video, I would like to cover 2 topics that I couldn't quite cover in my last video. I would like to show you how you can model compound gears, and I would like to show you how you can add chamfers to the teeth of your gears. I've opened up a new file, and I've already created the first gear. I will now go back into the gear generator and generate the second gear. This gear will have many fewer teeth than the first gear, and for demonstration purposes, I will also make it slightly thicker than the previous gear. And then we press OK, and then our second gear shows up. Now that we have 2 gears, we must combine them into becoming a single gear. So first we go to Solid, Modify, Move Copy, and what we will move is a component, and in particular it will be this smaller gear. And then we move that up by 20 millimeters, which is exactly the same as the thickness of the bottom gear. Next, we go to Modify, Combine, we capture the position, and the target body will be the lower gear, and the tool body will be the upper gear, and the operation will be Join. So click OK on this. And now if we look inside of our components, we see that one component has one body in it, which is our combined body, our complete compound gear, and the other component only has the origin and a few of the sketches. So this component is no longer necessary, so we can remove it. There is one unique aspect of compound gears that I would like to discuss. Most gears need to be fixed rigidly to their shafts because they need to be able to transmit torque into or out of that shaft. Compound gears do not need to do this, and so these must be mounted in a way that they can rotate freely with minimal wear and friction. This is most commonly done by mounting the gear to a shaft and then having that shaft rotate between two bearings. But I'd like to show you a different technique, and in this case the shaft is held stationary and the gear will rotate around the shaft supported by two bearings that are mounted inside of the gear. So we create a sketch on the top face of the gear and we will drag out a hole of 22 millimeters plus a little bit of space. And this is for a 608 bearing. Now you can of course use whatever bearing you like, but I'll just take 608 for now. I hit E for extrude and I pocket this down 7.5 millimeters. It's 7 millimeters thickness for a 608 bearing, and I give it a little bit of extra space to ensure that the bearing is not proud of the face of the gear. So we hit OK, and now we want a similar pocket on the other end of the gear so that we can have a bearing there too. So we construct the midplane, and we select the two gear faces, and then we go to create, mirror, and then we mirror a feature, which will be this pocket, and we mirror that around the plane that we just created, and we press OK, and then we have another pocket for another bearing. The final thing we'll do is create a hole for the shaft to go through. Now, we only want the shaft to touch the bearings, but not actually the gear itself. So this shaft actually needs to be a little bit larger than the shaft to ensure that there is no contact. So the 608 bearing is meant for an 8 millimeter shaft, so I will make this hole 10 millimeters to ensure that there is no contact. Finish the sketch, hit E for extrude, put that all the way, hit OK, and there we have a finished gear. The advantage to this technique is that you no longer need to create space for the bearings inside the housing of your gear train, and this allows you to make the housing a little bit more compact. The downside is that instead of the inner race, the outer race of the bearing is now rotating, and this causes the RPM limit of the bearing to be a little bit lower than the specifications would imply. However, usually I don't get anywhere near the RPM limit for a bearing anyway. I'd now like to show you two different techniques for adding a chamfer to the teeth of your gear. For the first technique, I've already created the gear in a generator, of course. We'll start with a sketch on this vertical plane. And first, I project the top and bottom surfaces of the gear into my sketch, using P for project. And then I draw a construction line going from the origin upward, and I'm looking for this perpendicular constraint. And then from the middle of this new line, I draw a horizontal line going straight out, and the length of that line doesn't matter. Next, using regular geometry, I draw a triangle like this, and I'll just give this some dimensions. Now, I don't want the chamfer just on the top face of the gear, I also want it down here on the bottom. So to achieve this, I will go for mirror and select this triangle, and the mirror line will be this line that we made before, and then we press OK. And now these two triangles can still move around. So what I'll do first is select this top edge and select this projected line and make these collinear. And now the only degree of freedom we have left is this side-to-side motion. So one thing you could do is make this point coincident with this point. But if you zoom in real deep on this area over here, you see that there are in fact 2 points very close to each other. So you run the risk that you would select the wrong one. So another way to do it is to select this edge over here and this central line that we drew before and set the distance between those. Now what must that distance be? Well, it'll be the module, which is 2, times the number of teeth plus 2, and that gives you the outer diameter of a gear. And set the distance between those. Now what must that distance be? Well, it'll be the module, which is 2, times the number of teeth plus 2, and that gives you the outer diameter of a gear. But we don't want the outer diameter, we want the outer radius. So we divide the thing by 2, and then the triangles are at the correct spot. Now we can finish the sketch, and then we go for revolve, and then the profiles will be both of these triangles, and the axis can either be the z-axis or this construction line that we made before, and then we hit OK. And then we have a chamfer that is a lot like the chamfer that a machinist would make into a gear using his lathe. I've now added a second gear to the design so I can show you the other technique. And for this, we simply go to the chamfer tool, and then we rotate our camera around a little bit like this, so we can draw a box that selects all the top edges of the gear, and then we do the same thing to select all the bottom edges of the gear. So we now have 100 edges selected, and we enter a distance, let's say of 1 millimeter. And this takes a little while to compute because it's quite a difficult geometry for Fusion 360. We hit OK, we wait again for a little while, and there is the second chamfer complete. Now, why would you want to add a chamfer to the teeth of your gear in the first place? And I can think of 4 reasons. First, if I delete this chamfer on this gear, and we imagine that these gears are made out of hardened steel, then this area over here, near the corner of the teeth, has a tendency to chip off. And one of the ways to prevent that is to preemptively remove the material, basically, by adding this chamfer. And a hardened steel chip inside your gear train will reduce its life very quickly. The second reason is that if you try to push these gears into mesh, these chamfers will help the two gears find each other so that they will go into mesh. Third, if you use the technique on the right here, the chamfer counteracts the effect of elephant's footing in your 3D printer. So if your printer suffers from a little bit of elephant's footing, then these edges over here being a little bit too wide will cause the mesh of the gears to be quite a bit worse. And you can counteract that by adding the chamfer that you can see on this gear. And finally, as this old Tony teaches us, the chamfer makes the gear look a little nicer, and you can charge more for parts that look nicer. I hope you found that interesting and informative. Thank you very much for watching, and have a great day.
And same.
Okay. Yeah. Let's see, how long have we been doing this? So maybe I should just build the real stack up. Because I'm happy enough with this using what, the M4 and just a set screw. I don't think it's exactly strong enough, but at some point I gotta get this thing done. Does this gear even have a, Dude, I hate when it does that. So how do we want to do this gear? Do we want to make it a circle and just use a set screw? Or I could do both. I could make it a square, but also have a set screw. Let's just do square only for now. So this is going to be center. Oh. 3.1, did I say? I did this somewhere. Where did I do this? Oh, I did this in the collar. Let's see. Can we open that up? Okay. Okay. Oh, wait. It's this one. And I haven't put in the gear. Ay, ay, ay. Now I feel like I should just build it in the real thing. So what is this piece? Gear holding beam. Derived. Okay, well, I don't care. I'm going to extrude this 25 more. Because we also need to make sure it's not going to hit this thing. So I'll make it 40. Okay, then we have this handle here. So let's go here. Okay, we got that point. What? Yes, so we want to move this thing. Okay, now it needs to rotate this way. Then it needs to come up. Probably 5 more, right? Is that it? Did I get it? No. Oh, it's going to be 12.5 minus 12.5. Right? No, it's some weird number. Thank God it's some weird fucking number. And now I'm moving the wrong thing, aren't I? Okay, well. This is just where I get so triggered. Like, you do all this work and then it just feels like it falls apart because of all this nonsense. In this case, it was the joint. And why is there a space there? Oh, right, because I redid this. But does it lose its threads? Yeah, it does, doesn't it? That's fantastic. Oh, that's great. That's what you want. Okay. Fine, I'm gonna go back to this one. I mean, what's wrong with this one? I don't think there's anything wrong with this one. I just need to delete these. And then I need to insert the other this. Where is it? Okay, so now do this. We're gonna select this component, move it up. Okay, now we're gonna J. No, bruh, no. Okay. And then we want to put it on that. Okay. And now we just want to move this down to here. Perfect. Cool. Okay. Now copy, paste, and then now let's do this more. Okay. Then we're going to joint this thing to this, but then we're going to move it up to this face. Okay, so now that's in there. Okay, now we want to insert our gear. And then, let's see, what is the distance if we inspect from here to here? 34, yeah, let's just extrude this by like 30 more. Wait, what? What? Dude, what? Oh, is it because I need to select this thing and I just need to extrude it by 30? Okay. I get it. I get it. I'm just upset. That's fine. Hopefully that doesn't like mess anything up. Okay, but now we need the gear. So I would like to just design the gear. Elsewhere. Let's just do it here. Okay, so this is gonna be, that's fine. This is gonna be 1. This is gonna be 20. This is gonna be 0.5. Gear thickness is gonna be 4. Hole diameter is 0. Okay. Then we want to construct and we want to make a rectangle that's centered, and we want to make this 3.2 by 3.2. Then we want to extrude this to here. Okay, then we want to, can we just move this over a little bit? Okay, then I want to joint this. I don't understand, dude. This shit is so crazy. It worked from the bottom, though. All right, and then we want to put that on here. And then we're just going to assume the plastic is strong enough to not deform, basically. And then we're going to just move this up to here. Okay, and then let's go back to the reference picture. There is another one on here, so then we're going to go to this collar, copy, paste, and then we're just going to move this to here. Plus 2.5, is that right? 3. That looks right. What does 3.5 look like? Okay. Okay, I think it is 2.5. Okay, so then what is the distance from here to here? Right now we're at 14. Shouldn't it be 15? Did I do something wrong? It should be 5 plus 4 plus... Oh, yeah, no. Okay. I don't know where that extra 0.004 is coming from. But then we need... And I think I'm just going to... I don't know if I want to add the other beam in. Okay, but let's just add the next shaft collar. I'm going to activate this. We're going to copy and we're going to paste it. Okay, then this needs to go how far down is the question. It needs to go so that the distance between here and this face is 36. So if we... So wait, let's cancel. Let's take this top one. Okay, so now we're going to move this down. Well, there's 2.5, right? It's because it's moving from this center point. So this is 36, and it's at 2.5 right now. So it needs to move 36 minus 5. It needs to move 31, I believe. So if we press OK, and then we inspect this and click on that, we should get 36. And we do. So that's perfect. Okay, so now, well, we really don't have that much room. Maybe you can like alternate back and forth to do it. And then that's a spacer, I guess. I can print a spacer. That's fine. That's just a hollowed out cylinder. Okay, and then we just need one more. So I'm actually going to take this crossbeam and copy it. And I want to rotate it, not that way. Oops. Oh, wait. Delete, delete, delete. Okay, I'm going to copy and paste this. Now I want to rotate this to be like that. But then I want to move it. Wait, is that right? No, that's not right. Why? What the fuck? I don't get it. Oh, you know what it is? I want to paste new it. I think I want to paste new it. Okay, I don't know. But we got to get it right on the first try, I guess. So this is the way that didn't make any sense. However, is it this way? No. So it is the way that I had it the first time. It's this way. Okay, I'm going to move this up by -2. Plus, and this is going to be 36. Why don't I just make the joint? Oh, crap. That thing is so freaking annoying. All right, I don't even want to do it. This is the stack up. And then we just have a 2mm gap here. So then we're going to take this, paste it, and we're going to move it down by 2. Or we're going to 2 plus 5. Okay. So there we go. That's it. There's so many spacers. It's insane. So that means we're going to need that many bolts or whatever, set screws. That's fine. All right, so let's try to do the second one then. So can I make this a revolute thing? Can I, how do I do that? I want to take this handle and make it motion link. Yeah, I don't know if I'm going to be able to do that. Look at all these planes that... Way too much construction geometry. Drive me crazy, bro. It's not even turning anything off. Where are these? Oh, for some reason origin is on all of these. It's probably because origin is like on somewhere and it got inherited or something. I don't really know. Okay, so that is the first layer there. So now we need to... I'm going to take that... So once this is done, I am going to print this out. We're going to see how it goes. It's going to turn... dude, I need to use a... This whole thing is stupid. It's going to feel like crap. This beam needs to be cylindrical. I mean, I'm just so dumb. Why did I make it a rod like that? I thought it'd be easier, but it's just gonna make it feel bad to use. Regardless, I think I'm gonna... It might not even work really because these are 5x5 and this is 3x3. So it has room to actually move this whole assembly 2 millimeters in any direction, really. Maybe that's too much play. Maybe I should just increase the size of the rod when I do this. But you can't do it by too much. That's why it needs to be... Let's see, how do they even do that? But these are square rods.
On the first axle can connect
Oh, that is the purpose of this bracket. I was on the train and I was like, what is the purpose of this bracket here? It's to prevent the I don't know how it does it, but it must have a smaller amount of play in there so that the gears can't really shift back and forth.
to a bigger gear on the second axle. This second axle can also have a smaller gear that then connects to a bigger gear on a third axle. Repeating this pattern will leave the output with a very little speed, but increase.
I wonder what because those rods look circular at the ends. I'm wondering if they... No, but that one looks kind of... Maybe they do. Maybe they are squares. Yeah, look at that gap there. Maybe they are squares. But still, this bracket is definitely to keep it in place. Well, we'll see how it is without the bracket, but I'm thinking it might not work, and we'll need to... Basically, the sketch would be... I think the sketch would be like... You have a circle whose diameter is probably like 3.4 or something. And then you have like a rectangle around this. And then 2 circles here. And then the distance between these guys is 30. So like the distance between here and here is going to be 30. And the distance between here and here is going to be this is going to be this is going to be this over 2. And then this we just make wider. And so then you put the shaft, or whatever you call it, through here, and it can sort of spin around in there without moving that much. But it's still not high friction, although that could be. Damn, I think I need to design this part. I don't think it's going to work otherwise. But I think what I'm going to do is end the stream and go to the gym once this finishes printing. So in the meantime, what I could do... I mean, I feel like I should just full send it. I'm going to print the handle, this long shaft, a bunch of these spacers, and a bunch of these M4s. And then we're just going to try to affix it to this thing. And then I want to print the next gear. So let's do this. Copy and paste this. We want to move this 30, right? Okay, but this one can be shorter, so we just need to move it like that. And I'm fine with having it jank like that because that's okay. Yeah, see how much play there is in there? This can just wobble. This whole thing can just wobble around. You're definitely going to need to put I'm definitely going to need to put a bracket there. But that's fine. That's 5. I can just use M4. I could just use these M4s to hold it in place. They're probably strong enough. Okay. So this is the more the same, right? Where does he show that? There we go. Yeah, so there's just a spacer at the end. We're going to skip the bracket for now because we can print them after. And then what I really want to do is I want this gear. And this is going to be modulo teeth 40. Then I probably am going to have to add backlash, but we're going to see how this goes. And these are 2 separate gears. Oh, wait. That's actually interesting. Yeah, no. Okay. So then we want to, first thing we want to do is we want to sketch on here. Rectangle, center rectangle. 3.2 by 3.2 by 3.2. Okay, then we want to extrude this to here. Okay, then we want to hopefully that's the nope. So let's take this, move it over a little bit. Okay. Joint that to oh wait, is there a spacer in the interior there? I can't actually tell, but it would make sense that there is. It doesn't actually look like there is, but I can't imagine that there's not. So before we do this joint, I'm actually going to take this component, copy and paste it. Paste it. I'm going to move this 30. And then now we can join this to here, but then shift it up to here. And then let's see. Okay, that's fine. I don't care about the intersection really, but that does look right if I were to rotate it. Oh, wait. Undo. Oh, wait, no. I want to redo, and I want to change this. Yeah, see, that's what I always get wrong. Is what you should do is instead of undo, because it removes so much, so we want this to be minus 70. If we look from here, that's perfect. And then somehow they affix this together. I don't know if this is one part or... No. It doesn't actually matter. It doesn't matter at all. So that's just some spacer. We could put the set screw thing in there just be totally fine. Let's see. What is... Toy Story is pretty good. Is Monsters Inc. Pixar? Oh wait, yeah, no, Baymax is what I thought it was. Where's a list of just every Disney character? Hopefully they're sorted. Oh, they're A to Z. That's kind of ridiculous. I don't know, man. I'm not the biggest. Dory's a pretty good one. Oh, Treasure Planet. Yeah, Treasure Planet's sick. Okay, yeah. There must be a Baymax model. Oh, little Baymax. No support Baymax. That's pretty sweet. It doesn't say. Okay. So, what should the spacing be then? The spacing should just be yeah, I say let's just do that, and then we're gonna copy. Yeah, we're just gonna use the exact same gears. That's actually so nice. So we can move this down by 5. That's not right. It's gonna be 5 plus 4. It's gonna be 9. And then here by 30. And then now now let's just put one at the end. Or let's put one here. So let's take this, move this down by 9 again, right? And then let's paste that and do another one. And this one needs to get moved down to here. Oh, wait, no. This needs to get moved down. It doesn't give me a plane. I don't know. It's going to be 5, 10, 15 plus 8 is 23. So 23. So is it 13? Oh, wait, crap. Wait, I'm gonna cancel. This, move down. Can I select this? No, see, that's not what I wanted to do. So we want to move this 13 down. Did I get it right? I honestly can't tell, but I'm gonna say I got it right. And then we're gonna move this down. What is it? It's 7. Okay. So many spacers, bro. Okay. So I want to do this. All right. Actually, let me just do this, this, and that. And we're going to copy and we're going to paste it. We're going to move this by 30. Okay. Then we're going to take this spur gear and move it up by 9. Oh, minus 9. Then we're going to move this one down by minus 9. Oh wait, actually, no, we need to delete this one. Sweet. All right. So maybe I should just get saving 2 designs. Oh, no. Well, whatever. This thing is too long, man. That's a much more reasonable. Oh, nice. Let me go get my stuff. Okay, so there was whatever. So the set screw, it was too thin to make that little indentation for the Allen wrench, so that didn't go as planned. And then I never actually printed out the M6 nut, which is annoying, so I can't really test how well this thing works. But I think I should just send it. So the handle, the handle I need to save as mesh. I never saved the handle. Okay, cool. I don't know why it always switches windows. All right, gear holding beam. Save as mesh. Okay. Wait. Okay, so we'll do V3. Okay, now I need this thing, which I think I have. I think it's in here still. Like, wait, what? I did print it. Did I miss it? Where did it go? Hold on. Okay, so I did find it, which is nice. Then you want to put flats like that. Okay. There we go. Now it's basically in there forever. Well, actually, maybe I could get it out. No, I don't know. And then we don't have a really long screw. And this set screw is not going to do it. I shouldn't have made it 10. I should have made it way more. Well, anyways, let's just get this print going. So, delete this. We need 2 of these beams. Okay, we need set screw collar. We need 1, 2, 3, 4. I'll make 7 of them. 1, 2, 3, 4, 5, 6. Okay. Then we need the handle. Handle. Then what else do we need? We need we need the gears, which are the most important parts. And the gears, oh wait, I don't think I did that right. Okay. Okay, now. Okay, nice. That tool is so useful. Oh, and then we need the set screws, which I'm just going to use M6 for that with the head on it, because then I can actually do it. So my library, M6 2x10, that's the one. Okay. Then this guy, 1, 2, 3, 4, 5, 6. Okay, now we want to arrange them all again. Nice. Cool. All right, that's it for the stream. Basically, what do? We got more familiar with gears and Fusion, which is good. We made this, which actually is a full, it doesn't have the washer thing, but it's, I guess, a properly done gear with a mounting hub. And then we printed out the parts for this assembly. And then we can just start assembling, which is nice because after this print, presumably we'll have meshing gears, which is really cool. But that's it. Peace out.